The vertices of quadrilateral ABCD, in that order, are given here. First, plot the points and draw ABCD in the coordinate plane. A is -1, 3. Put an A. B is 4, 3. 4, 3. Put a B. C is 2, -1. And D is -3, -1. -3, -1. Now, when they say draw ABCD, we literally must draw it in that order, from A to B to C to D, and then continue by connecting to the first point again. First part, done. Plotted the points, connected it. Second part, find the slope of each side of ABCD. So, what is slope? Rise over run. We can count it. First one, from A to B, that side right there. So this is how we write it. M for slope, subscript AB, meaning we're connecting from A to B. Well, it's just a horizontal line. There is no rise. Remember our hoi, vux, horizontal, slope of 0. So the slope of AB is 0. Looking across to the opposite side, right, opposite from AB is DC. I'm going to do that slope next because it's also a horizontal line, so it looks easy like the first one. Slope is 0. Now let's do the slopes of the other sides. How about the slope of AD? If I'm going to do rise over run, I'm going to start with the point to the left. So from D, I'm going to count up. 1, 2, 3, 4, and over 1, 2. Simplify it to 2 or 2 over 1. Similarly, the slope of CB or BC, this guy right here, again, I'm going to start with the point to the left, and I count 1, 2, 3, 4 up and over 2. So the slope is again 2 or 2 over 1. Now the next question is ABCD a parallelogram? Well, what do slopes tell us? I see here these slopes are the same. When slopes are the same, those sides are parallel. So side AB is parallel to side DC. What about these? Also, these slopes are the same. So AD is parallel to CB. What does this tell us? That both pairs of opposite sides are parallel. Isn't that the definition of a parallelogram? Yes, it is. So my answer will be, therefore, yes, ABCD is a parallelogram. Let's try a similar example, but this time we are looking to find the fourth coordinate. 3 vertices of parallelogram ABCD, that tells us it's a parallelogram, are given. Find the coordinates of point D. So we're going to plot the first 3 points. A is -2, 1, 2, 3, 4, 5, 6, 7. B is 3, 6. C is 5, 1. And D, I don't know where it is. Let's connect the first 3 points. A to B, B to C, and C to I don't know where. Well, remember about a parallelogram is that the opposite sides are parallel. Think about what we just did. We counted slope. So AB, this side right here, should be going in the same direction as the side that connects with C. So let's count how this one looks. From A to B, actually from B to C may be easier. We go up 1 and over. So from B to A, up 1 and over 1, 2, 3, 4, 5. So similarly from C, up 1 and over 1, 2, 3, 4, 5. Just counting in a similar way. So now we can connect from C to where we think D should be, and let's check to make sure that looks like it's in the correct place. If we connect from A to D, let's check the slopes of these sides and make sure it's the correct way that we should count. From A to D, 1, 2, 3, 4, 5 down and over 2. From B to C, 1, 2, 3, 4, 5 down and over 2. It does look like we're counting the same amount on opposite sides. So how do we answer the question? Find the coordinates of point D. Where is point D located? Well, here's the origin right here. So from the origin, we just go up 2 units, so therefore D is at the point 0, 2. We did it!